Hey everyone, Pat here. Welcome back to the channel. I had no intention of making a video 5 minutes ago, but the mood has struck. And I wouldn't make another Ampeg video because I made a promise to myself that I have bombarded the hell out of you guys with Ampeg content. So here's what I want to do. We're going to make a video about capacitors. So first, the amp. Client brought this in. This is a insanely clean 1961 Ampeg 625D. This is a very unusual rare amp. So the client already changed the electrolytic caps, filter caps, cathode caps, and that's what you want to do with an amp this age. But that didn't fix the problem. Then the client changed just about all the tubes. That didn't fix the problem. So then he brought it in here. So what is the problem? Well, I heard it right away. Leaky coupling capacitors. When these caps start to leak, what happens? Well, first symptom, it will start to sound very distorted, especially when you dig in, and then all the pots become dirty because DC is leaking onto the pots or onto the grid of a tube, and basically you have DC voltage where you shouldn't have voltage. So in the real world, what does leaking coupling capacitors sound like, and what does it look like? Well, these scratchy pots, it's not because they're dirty, it's that DC voltage is leaking onto them. Now with the guitar, it's going to be overly distorted, especially when you dig in and play a little bit harder because the DC leakage will actually tend to rise up. So we start playing light. So let's backtrack for a moment as to what is a capacitor. So a capacitor stores an electrical charge, and you have two plates that are very close together. They don't touch. If they touch, it shorts out, right? You have two plates that don't touch, and inside you have an insulating material called a dielectric. It could be air, like the old tuning capacitors of a radio, or just these big plates that move across from each other. You could have oil, like in this cap here, right? Get the mic there. There's oil inside. The older caps, often you'll have paper as an insulating material. And now often with modern capacitors, you have different types of plastic. So even in the most simplest of amps, you're going to have two types of capacitors, a coupling capacitor and a filter capacitor. So if a capacitor holds a charge, it's very simple to imagine what it does in a power supply. So it filters the ripple. So AC voltage comes out of the wall, and then the power transformer steps it up in a tube amp, and a rectifier turns that AC voltage into DC. But it's not smooth, straight DC. There's a big ripple. So we need capacitors in the power supply that are going to charge up when the voltage goes up, and then when the voltage wants to go down, they release. So the capacitors will smooth out the ripple to give you very smooth DC. That is needed in every amp. And the coupling capacitors will couple two stages together. Another thing a capacitor is going to do is it's going to block DC. So if I have 400 volts on this side, DC, I'm going to have 0 volts on this side if the capacitor is working correctly. Like with that Ampeg, we were leaking. So but it will, a coupling capacitor will let the AC go by. So pop quiz, music, is it AC or DC? It's AC. We hear AC, right? Hit a guitar chord, that's AC voltage. So you can have AC riding on DC. So again, for an example, we can have 400 volts DC, and we could put a 10 volt sine wave on that DC. We hit the capacitor, and then on this side we have 0 volts DC and just our 10 volt sine wave. So I want to show you visually really quick how filter caps are working in amps. So here's our AC in, our power transformer. This is a schematic to the actual 625D. We have our rectifier. So let's just say here we have 450 DC as an example. After that rectifier, if we don't have caps, we're actually going to have all of this ripple. I'm not an artist. The capacitor, right, will charge on the peaks and discharge when it starts to drop. So it's going to give you straight DC. Fills in these holes here. So what you want in a power supply, straight DC. Now we talked about voltage. You can have 400 volts DC right here, and you can have 10 volts AC riding a sine wave, your guitar signal, right? Now for the coupling capacitors. This is our input jack here, jack 1. Our guitar signal is going to come in. We're going to have voltage here, right? Let's just say we have 100 volts DC. We need to block that DC because we're going to go into our tone controls and then our next stage. So we're going to have 0 volts DC here. This capacitor, the coupling capacitor, blocks DC but passes AC. So our guitar signal is going to go through our tone controls, right? Which is going to have resistors and capacitors for our tone shaping. Then it goes to the next stage. And then here's another coupling cap, right? So let's just say again, example, we have 100 volts DC here off this plate resistor. We want 0 here. So at this volume control here, we want to have 0 volts DC, but we definitely want to have our AC signal. If we look at this 100K plate resistor here, okay, so we have 95 volts on one side and the other side should be 0, but of course we have that leakage, so we have 6.8 volts. These are all leaking. We can go right through all of these here. We have voltage everywhere. 5, 6.9. As capacitors age, they tend to drift up in value, coupling caps. Now in an amp, that's going to make the amp darker. So when you get new capacitors in, all of a sudden your amp sounds a lot different, sounds a lot brighter. Maybe that's not something that you want to hear. It's all subjective really to what you're doing and what sounds good to you. So when you do change capacitors in a vintage amp, it will change the sound and generally make it more brighter and more lively. And we're talking about value here, not just the leakage aspect. So let's come over here to some of this test equipment and look at some of these old caps and how they compare to a new cap. Let's test this 0.05 600 volt red Astron. The value is 0.068, so it's drifted up a little bit, not crazy, but it's drifted up. ESR, which is telling me that it's leaking and it's actually acting a little bit like a resistor. That's not good. And here is our leakage. We are applying 600 volts to one side and we absolutely are leaking across. Now I'm going to compare it to a new capacitor. Now I have a 0.047 brand new orange drop. Our value, dead on. And leakage, nothing. I'm going to show you guys some old capacitors, and a general rule of thumb, if you have an amp that has these old bumblebees in them, they're so pretty, I love these. They're probably bad. Wax caps, I love wax caps. They're in a lot of old 50s radios. I've changed a lot of these in my life. These are almost always bad. Unfortunately, yellow Astrons, they sound good, but these have reached an age where often these are bad. Red Astrons, yeah, these generally are bad. They deteriorate, they just get old. But in like your black panel fenders, your blue molded Ajax capacitors, these things are amazing. They last and last forever. So if you have a black panel amp that has these in them, I'd be shocked if they're bad. Do not change them out. There is no reason. They sound amazing, and there's no reason to change out caps, good quality caps that are working fine. You know, I don't recommend every 10 years change every cap out of an amp. Now, if you have an amp with cheap caps, if you have an amp with cheap electrolytic caps that are 10, 15 years old, yeah, sure, change them out. I would. But as a rule of thumb, you know, there's not a rule of thumb. You know, you have to use your brain a little bit. And, you know, people have different schools of thought and different theories, but a cap is a cap. And, you know, we shouldn't be so afraid to change them, but at the same time, it does affect the sound. And different caps have a sound. And if you change out caps in your vintage amp, it's going to change the sound. They make a lot of caps now. I really like Jupiter caps. They're reproductions of old caps. There's the mustard caps they make now. There's Sozos. There's a lot of caps now that sound really good that you can get. And orange drops actually sound really good. And Mallory's sound great. In my hi-fi amps, I use copper foil caps. They sound so amazing and transparent. But guess what? In a guitar amp, those caps, they kind of sound like ass. The hi-fi world and the guitar world is opposite. Too clean and not good for a guitar amp, and you don't want a hi-fi amp that's dirty. When you have bad filter caps in a power supply, what can happen? Well, I'm going to show you a video I made about 3 years ago of a Sano with a really bad hum. Okay guys, I want to show you the sound of bad filter capacitors. All right, where was I? So in a power supply in that first stage, if you have a bad cap, you're going to get a bad hum because you have ripple right there on your power tubes. But you have dropping resistors and your power supply goes down the line to reverb and preamp, etc. So what happens if one of those capacitors starts to fail? Well, weird problems. Oscillations, ghost notes, this weird kind of ring modulation octave thing could happen. So there are other issues besides a bad hum. Reverb hum. Usually that's a reverb problem, but it could be a filter cap problem. If a cathode cap goes bad in a preamp tube, you can lose some gain, you can lose some low end response. If a cap on a bias circuit goes bad, bad news bears. You can just have tubes shorting out, and you can have a bad hum. So these are some of the other things that you can get besides that massive awful hum I just showed you with that Sano. So when you're changing capacitors, it's very important that you change them with the same value. If you're taking out a 0.1 microfarad cap, put a 0.1 microfarad cap back in. Same thing with filter caps. You don't just want to put in a 300 microfarad cap when it's supposed to be a 22 because you think you're going to tighten up the low end. And yeah, I gotta tell you, tube rectifiers don't like a lot of capacitance. So it's very important to put the correct cap in. Now let's talk about voltage. So besides the capacitance value, you also have the max DC voltage value. And it's very important to be mindful of that. If you take out a 600 volt capacitor, don't put a 400 volt capacitor in. If you exceed that value, you're going to damage the capacitor and the equipment. And you want to be mindful with power supplies, especially with AC wall voltages being different and being much higher now with tube amps than they used to be. And if you got a solid state rectifier in there, you can exceed the voltage. So be very mindful of that. Also be mindful of the ramp up time with DC voltage. You turn on a tube amp, solid state rectifiers, you can get a spike in voltage. Once the power tubes start conducting current, that voltage will drop. So you got to be mindful of that and make sure you don't exceed that max DC voltage. So here's an F&T branded 22 microfarad cap at 500 volt max. Here's a Mallory, a 0.22 microfarad capacitor at 630 volt max. So the unit of measurement of how much a capacitor can store is in farads. Farad is a very big amount that something can store. So we're in electronics that we're dealing with microfarads or even smaller, something like picofarads. So like a bright cap, which would be 250, 100, 500 picofarads, that's going to be the smallest value capacitor in an amp. Coupling capacitors, which we talked about, could be common values or 0.01, 0.02, 0.1, and then filter capacitors. They can range between as little as 8 up to about 220 microfarads. Filter caps and cathode caps and bias caps are polarized, which means there's an orientation. There's a negative side and there's a plus side. So on a filter cap, for example, you're going to have the negative side is going to be grounded and the positive side is going to be to your power bus. Now, in a bias supply, it's usually reversed because that's negative voltage being applied to the grid of the power tubes. It's important to get the orientation right in electrolytic caps, or you can damage the equipment and certainly destroy the capacitor. Coupling capacitors don't have an orientation. They can go in any direction. However, it is best practice to make a notation of the orientation of the outer foil. So if you look at an old fender, you're going to see a line that's usually toward the high impedance side, and make sure that you install a cap the correct way. It is best for noise, but modern caps really have really good shielding, so it is not as important for audio work now as it used to be. If a capacitor can hold a charge, can it hold a charge when the amp's off and it's been sitting for a couple days? The answer is yes, and this is what makes it a little bit dangerous. So this is where we talk about discharging capacitors. For safety, you always have to discharge your capacitors before you work on an amp. So in the shop, I have a 5K 10 watt resistor that I go across each capacitor and I discharge. And every amp's a little bit different. There's a lot of amps, especially the big ones, where you have bleeder resistors or stabilizing resistors across capacitors, and those resistors will eventually discharge the amp. But you can also have a problem in an amp. You can have something disconnected and you can have a charged cap that's not being bled through. What's my point? Best practice for safety is to go through and discharge every single capacitor, especially if you're new to working on amps. Another thing to know about capacitors is 2 capacitors in series will divide and 2 capacitors in parallel will add. So for example, if you have 2 20 microfarad filter capacitors and you put them in parallel, you now have a 40 microfarad capacitor. But the voltage does not double. So let's say each one's 500 volts, you now can't put 1,000 volts across that. Capacitors in series will divide. But let's say you take 2 40 microfarad caps, put them in series. You now have a 20 microfarad cap, but the voltage will add. So if each one is 500 volts, you now have 1,000 volts that you can put across. And in ham radio equipment, you're going to see a lot of that. And the big boys, big SVTs, big Ampegs, and other trainers, you're going to see that too. But it also is best practice to not just be putting capacitors in series in parallel, or to be putting them in series without adding resistors, stabilizing resistors across each one. All right, guys, it is time to go home for dinner, and it's time to wrap up this video. I hope you guys enjoyed it. There was so much more to talk about with capacitors, but I wanted to do really in the context of working on guitar amps. Got a lot more videos coming up. Sorry, I've been MIA for a minute. Just got a lot going on. Let's finish out this video with a clip of that Ampeg after we changed the leaky caps. Boy, it did sound good. So, guys, take care. See you soon. Peace.